Hi folks, we're going to take a look at a second example of solving an exponential equation. If you take a look at this one here, I think it's pretty clear that you won't be able to write both sides of the equation with a power on one side or power on both sides. Okay, so we're going to have to come up with some other method for solving this. Okay, and I want you to focus in on this first expression here, 4 to the x plus 2, and I'm hoping that it makes you think of something in particular, that it makes you think of the first exponent law. Because with the first exponent law, you know that you multiply two powers with the same base, and the result is having to add the exponents. Okay, so I'm going to go the other way. I'm going to write this now as a multiplication of two powers. So 4 to the x times 4 squared. So if I go backwards, it becomes 4 to the x plus 2. Now what's nice about this, we're going to see that this is going to come up as a common theme, is I'd like to get the same power appearing as much as possible in my equation. So now I had already a 4 to the x, and now in this expression here I have a 4 to the x on its own, as opposed to 4 to the x plus 2. Okay? So question is, how is this going to be useful for us? Well, if you look at these first two terms, you realize that that 4 to the x is a common factor between those two terms. Okay, so now we're seeing how we're going to use our old methods for solving equations, okay, and incorporate them in solving exponential equations. So if I factor out the 4 to the x, here we're left with just 4 squared. Okay, and then here, well, if I divide 4 to the x by 4 to the x, I'm left with 1. Okay, so what I have is I just have some number times 4 to the x. So what I'm going to do is I'm just going to take that 12 to the other side, and we're going to see that we're going to be able to solve this quite easily now. So 16 minus 1, so we've got 15 times 4 to the x equals 12, and I can now just solve this with opposite operations. Okay, so I have 4 to the x equals 12 over 15, which is 4 over 5. Okay, and now I have a form for which I can use logarithms. Okay, clearly I'm not going to be able to write 4 over 5 as a power with base 4. Okay, so here I'm going to take log base 4 of both sides. So again, log base 4 of 4 to the x, since they're inverse functions, is just going to leave me with x, and on the right hand side I'm just going to have log base 4 of 4/5. Okay, and there you go. There's our solution. Now this is an exact answer. Of course, if I wanted to get an estimate for this result, if it's being asked of me or if this is part of some application question, I would of course just rewrite this in terms of log base 10. So change of base form, that tells me that this is log base 10 of 4 over 5 over log base 10 of the original base, which is 4. Okay, I wouldn't expect you to do this unless you had to do it to use your calculator. Okay, so let's recap. Okay, if you can't write it as, one power on each side of the equation, what you want to look for is how to turn each of the expressions into expressions that contain the same type of power. In this case here, 4 to the x, and here we're seeing that looking for common factors is also a useful process in solving exponential equations. Okay, that's it for this one.